Welcome to the Databricks Skill Builder series. We're glad you're here.
All right. Thanks, Stephanie. So my name is Tomas Batsevich. I'm a solution architect outside of New York City. And I'm here to talk today about a blog that I wrote in conjunction with Greg, a product specialist for the platform team, on cost management. And so first, maybe before I get into the presentation, this is the actual blog, and that's a link in the actual presentation. So we can send that over later. But generally, I'll be going through mainly what is covered in the blog here. So let me just get started. First slide is, before we get into the actual content and talk about what how we can control costs and all that, I just want to mention first that this really is mainly around from an administrative perspective, in the sense that we're not looking at ways to optimize queries or Delta tables for to optimize cost, right? Where you maybe are able to run queries faster or something like that. And we're also not looking for detailed ways to optimize your cluster sizing for respective workloads, specifically at least. But it's more of an administrative kind of task where administrators should be able to go in and manage an entire organization to make sure that those users within the organization aren't just wildly bringing in a lot of costs by using a lot of resources that are unnecessary within Databricks. And that's really the purpose of this conversation here, is just to make sure that the admins know of the different ways that they can control those costs, and then also be able to actually monitor those costs through different mechanisms of making sure that you understand who's actually who should be charged if there's cost centers within your organization, for example, and so on. And so the two main points here I'll be talking about are cluster policies and usage monitoring. So with that said, first, let's just quickly level set, right? I'm sure most of you already use Databricks and know what a DBU is, but just to kind of clarify it, DBU is really our unit of measuring the amount of usage of Databricks itself. And DBUs are typically correlated to the number of nodes that you're using in a cluster, as well as the computational power of the underlying virtual machine. So if, for example, you see virtual machines that have more memory or a better CPU, they typically cost more on the VM layer as well as on the DBU layer as well. And so again, I'm sure you're also familiar that everything in Databricks is really built by only compute. And so that's why the DBU exists. And then from there, we have calculators. So if we quickly go into one of these calculators, I can show how, we might have a different rate for a different type of compute. So whether it's an all-purpose cluster or there's a jobs cluster that we can have, all of them have a different rate, where once a DBU, which is billed by the minute, once we figure out, let's say we use 1 DBU per hour, then we're going to get charged 20 cents for that compute for any jobs cluster that we're running, right? And 65 cents for an all-purpose compute cluster. Obviously, these are list prices, so that's typically how it works with the standard pay-go when you're using Databricks. So with that said, definitely a great place to look at those calculators to figure out how much your costs typically are. And then when it comes to actually converting those DBUs, like I said, it's a workload type. And also, if you also notice, there's a subscription tier. So there's different tiers of subscriptions. Typically, enterprise customers are using the enterprise or premium versions of our platform, just because those are the ones that give us the best security and compliance that's needed to deploy in enterprise workspaces or enterprise environments. And then just a note here, you also see that we also have obviously SQL warehouses. So not the standard clusters that you're typically using with Databricks, but also the SQL warehouses where you might be doing SQL workloads. And those are essentially groups of clusters. And so roughly the DBU rates for those is the sum of DBU rates of those clusters that are making up the endpoint. So they're obviously charged a little bit differently, but also kind of on a similar basis. So now let's just quickly get into cluster policies themselves and really the main mechanism for how admins can control the costs within their organization. It's first most important to note that there, by default, when you deploy a workspace, there's a setting of unrestricted cluster creation that's available to uncheck within your workspace settings. And the reason why this is important is once you want to control costs, you want to restrict the amount of compute that users can create. And you have, the only way you can start doing that is if you uncheck the checkbox that says unrestricted cluster creation, because otherwise anyone has, an organization has access to create any compute if they have access to actually create a cluster themselves. And then with that said, it's important to always keep in mind what the actual use case is for the clusters that are being used when cluster policies are being created. So cluster policies, maybe just to take a step back, are a way for us to define what are the different boundaries of what kind of cluster someone can create within Databricks. And so I'll go a little bit into details of what are those specific, parts of the compute that can be controlled. But it's important that when we give out as an administrator these cluster policies to our users in our organization, we also have in mind what use cases those personas are typically, or users are typically running. And I'll get a little bit into some of the details there, but just something to keep in mind and really important to always think about when we're talking about cluster policies. And one last thing here is that you'll see that when we create these policies, we can make things that are less restrictive or more restrictive based on the types of policies that we create, where, for example, we can force users to use only a specific VM type or only a specific like Spark version, for example. But then we can also give them a range through using things such as allow lists or regex. And then we can also hide some of these settings when they are actually creating these clusters, so that maybe, if we don't want them to even know that that function exists in creating a cluster, we can hide it altogether. And it's important to note that just the way I was mentioning earlier with the use case driven approach of creating these cluster policies, it might seem that it's a great idea to have some super strict cluster policies that really restrict users so that they can't run up costs. However, we'll find that typically organizations that do this end up still having high costs because there's multiple reasons for that. For example, if you have very restrictive policies on jobs that need to, let's say, finish in an hour, but the user doesn't have an ability to create a cluster that's going to be able to finish a job within an hour, it might take several hours to finish that job. And because of that, the actual cost of that job running could be a lot higher because it's just taking a lot longer time to finish. And then the other aspect of it is that you end up lowering your adoption rates if it's too difficult to create a powerful cluster for end users. But on the other side of the spectrum, you also obviously want to make sure that it's not too flexible, because maybe there's a new user that's coming into the platform and then they have a very flexible cluster policy that's assigned to them. And now they create a 20 cluster or 20 node cluster when in reality, they need a 5 node cluster for the workload that they're trying to run. So it's a balance of understanding what the use cases are and who we're actually giving these clusters to or cluster policies to when we're creating them. And so now let me just get a little bit into some of the specific aspects of clusters, right? And if you're creating a cluster, you're probably familiar with the different functions and settings that you can have when you're creating a cluster. And all of those settings are typically available to be controlled by policies. And so that's where, for example, auto scaling is a super important feature that can really result in a lot of cost savings for your organization. But it's also important to note that if you're an administrator and you're giving these policies out, you want to understand those use cases, like I mentioned earlier. And the reason for that is because with auto scaling works really well for certain things, such as shared all-purpose clusters. So if you're, for example, creating a cluster and you're sharing it across many different users, it's great to have auto scaling enabled so that as a new user attaches to that cluster, then it detects that there needs to be a need for more nodes to be added to that cluster, and then it automatically auto scales, right? And also, if you have long running batch jobs, which you don't necessarily have a time sensitive kind of SLA for, where you can have it run for a while with varying complexity, where maybe there was a specific part of the job that it takes a whole bunch of memory, and then another piece of the job that requires very little memory. It's great to use auto scaling in that regard, but auto scaling does slow down those workloads a little bit, just because you need to have those VMs up and start every time you upscale, and then it shuts those VMs down when you're downscaling again, right? So it's kind of a balance, and again, it's really it for those non-time sensitive jobs that you might want to use auto scaling for. However, then there's also jobs that you don't want to use it for. So time-sensitive jobs, like I just mentioned, especially if you're looking at something that you want to run once every hour, and you need to finish it within that hour, for example, you don't want to necessarily have auto-scaling bog that process down. So then you should figure out, well, what is the actual amount of nodes that's needed to run that job, and then have that setting there without auto scaling. And so as an administrator, we need to understand that difference, right? So that when we are giving those policies to a team that might be running time sensitive jobs, we might make sure that we're not enabling or forcing them to use auto scaling when creating those clusters. And then there's also streaming workloads, where oftentimes traditional auto scaling doesn't work well, because it might auto scale up, but then it doesn't necessarily auto scale down, because it has a hard time detecting when resources are not being utilized with streaming workloads. However, the great part of this is that if you use Delta Live tables, and if you don't yet, you should, especially for streaming workloads, because we built Delta Live tables with streaming workloads in mind, and we have what we call enhanced auto scaling, which is actually, I think, recently gone GA, literally this week or last week. And it's a great alternative to the traditional auto scaling, which does a much better job of scaling, and you should potentially use that instead. So again, that's where we can kind of lead by best practice when giving out these policies to different teams once we know what the workloads are that they want to run. And just one note here is that if you, for example, do have a team that does really, that wants to use auto scaling, but they also are a little concerned with the performance of upscaling, for example, their clusters, you can also leverage instance pools. So instance pools are typically warm VMs that you can automatically take to use within your cluster, and that reduces heavily that upscaling time for your cluster. Right. And so this is just one quick example of when you're creating that cluster policy. And I'll show you in a short right now, actually, what a cluster policy definition, where you define it. But typically, it's a JSON represented kind of setting. And as you see here, this auto scale setting allows us to say that we can have a max value of 10 workers, but a default value of 5, and minimum value of 1 worker. So that means that, let's say you're giving a policy of this type to a user who wants to create a cluster for an all-purpose compute. It means that that cluster that they can create can always auto scale down to just 1 node, right? But it can also scale to 10 nodes, meaning that if they want to have a shared all-purpose cluster, they might want to have other users attached to it. So it can ultimately support a few users on that same shared cluster, right? But if, let's say, everyone disconnects from it except for maybe 1 user, and they're not really utilizing all those nodes, it can easily scale down to 1. And maybe just real quick to make some sense of what I'm showing here in terms of a JSON. If we go into the compute here, and if you're an admin, you should see this policies tab. So within it, you can actually create a cluster policy. And this is where you would define that JSON that I'm showing right there to pretty much specify who's able to access what, right? And then you can give those permissions out to a user or a group or whatever to make sure that they can only use those policies that you've actually attached to them. And just by the way, also, once those policies are actually given to a specific user, if you go in, you see I have an unrestricted policy, and that's because I'm an admin, so I can do whatever I want. But if I was an admin and I removed the workspace setting of unrestricted policy, the unrestricted cluster creation policy, then I would only be able to see the policies that have been attached to me. And so once you select one, you should be able to see how there are certain things that are kind of, telling you that you have to use this or that. It's pretty much forcing you to make the cluster within the specified set of rules that you've created within the policy. All right, so going back to the presentation, another aspect of cluster policies is single node clusters, which are often very useful, even though it might not necessarily seem like an obvious thing to use. But single node clusters are especially useful for users that are new to the platform, for example. So someone that's just trying to explore and understand how Spark works, or how to ingest their data. Single node clusters are great in a way to explore it without running up the costs. And also a lot of machine learning teams still use libraries that are single threaded, meaning they don't use distributed libraries. So those single node clusters can really be valuable for some of those teams. And in that way, we're ensuring that they're not creating a 10 node cluster when in reality, maybe a machine learning team might be actually just using a single node to actually run their models or train their models and so on. And another important thing to note is, imagine if, for example, you're an admin and now you have a team that you want to onboard onto Databricks, and you, let's say, have 10 different users, but they might be using Databricks at a different time. You want to assign all of them just a single node cluster so that they could use the single node and try out Databricks. But you might also want to restrict the amount of clusters that they can actually create. You can also restrict them to a specific instance pool. So you can create an instance pool and say, well, we only have 5 VMs for this team, and they can use those 5 VMs in any way they want. But that also means that at any time, you can expect at most only 5 VMs being run for that entire team based on that policy that you've given them. So it's an important mechanism where you can also control the total amount of actual clusters that are being utilized within an assigned team, is that instance pool. And then another thing to note here is that we've added this new capability of a personal compute cluster, which is actually exactly for those new users, right? Where they can easily go in and just click a button and have a single node cluster to let them explore what Databricks does and how powerful it can be without running up the costs by having a very powerful cluster that they create. So with that said, another important feature of cluster policies is auto-termination. I'm sure you're familiar with this feature, but it's important to note that it's something that really doesn't have any downside when creating a cluster policy. And the reason for that is because imagine you have someone that is creating an all-purpose cluster, and you just want to make sure it shuts down after some time if it's idle, right? And so that's where it's very important for a cluster policy to set some kind of time to say, well, let's make sure that it turns off after it being idle. Maybe someone forgets every night to turn it off, and it just runs all night without anyone actually using it, right? You don't want to run up those costs in the middle of the night. And so that's where the auto-termination policy can really help with that. And the typical setting there is 60 minutes. Sometimes it's 2 hours, so 120 minutes. But it's especially important whenever someone has the ability to create an all-purpose cluster. And that's where you see an example here as well, where we're just forcing the cluster to shut down at 60 minutes. And let's say if we also want to make sure that the user isn't even doesn't really need to know that we shut this cluster down after 60 minutes, we can hide it as well. So kind of forcing users into some of the best practices of creating clusters. So then when it comes to, kind of pushing best practices by example. So, and what I mean by pushing best practices by example is by giving good cluster policies out to your users. Another important feature of cluster policies is being able to select the runtimes that are being used for your clusters. And in this case, what I mean is that if you look on this little graph here, I mean, it's a little outdated now, oh, sorry, but in Spark version 8, which was a while ago because we're in Spark version 11 now, or Databricks, I'm sorry, runtime 11, not Spark. Then you'll see that with every release of Databricks runtime, we are able to really speed up our workloads, right? And because if we can finish jobs faster, we're going to have lower costs because overall you're just paying, for less time of compute, really, right? And so that's why it's important to, through cluster policies, enforce that users are using some of the newer runtimes so that they're not running some old runtime, which might be really slowing down some of the workflows that they're currently running. So that's an important feature of policies. Is also just kind of like pushing users to use best practices to make sure also to lower those costs. And that's where also Photon comes into play, where you can enable Photon. Photon is especially valuable when you're running batch jobs or even streaming jobs, and you want them to finish at a certain time, where maybe Photon, has a different rate in terms of GPU costs, but because it has such a faster speed up, that it's typically valuable to use Photon over not using it. But again, it's important to work with those user teams that are creating these jobs to understand, is Photon, really speeding the process up, which in most cases it is, just because we've really optimized most operations within Spark using Photon. So that's just something to keep in mind here. Yeah, and then there's also another thing to consider is cloud instance types. And so with cloud instance types, this is where we really want to think about the use case as an admin is creating these policies to give to end users, because you can have sometimes cloud instances that are, let's say, very high in memory, other ones that are very powerful in CPU and have a lot of cores. And it's good to understand the use cases that those end users will be running on top of these instance types so that we can provide the right restrictions, but also the right flexibility in those cluster policies so that they have access to the right VMs, right, that they can use within their clusters. And again, it's important to understand that if you're going to have a very small cluster or very small VM for a cluster that it maybe requires a lot of memory, it's going to heavily slow down those jobs. And so ultimately, you'll find that those costs could be very high because those jobs are just taking too long to finish. And typically when it comes to new teams that are less experienced and probably not running very complex workloads, it's usually better to start out with giving them smaller instance types as they progress in their knowledge around Databricks and and scaling their clusters in the right fashion. That's where it makes sense for them to try out maybe larger instance types, and that's where maybe you give them more flexible instance types with the cluster policy that you create. And just one shout out here, AWS Graviton is a great option to actually lower those costs where, as I mentioned earlier, where GPUs are one aspect of what you'll be billed for from Databricks, but also the VMs that you're using in the cloud provider will also be, part of your bill. And because of that, using something like an AWS Graviton node is very cost saving because they're typically a lot cheaper. And AWS studies have shown that when it comes to price performance, they're some of the best CPUs out there for the ones that AWS offers. So if you're using AWS, definitely consider using the Graviton CPUs. So then another great feature of Databricks is the ability for us to use spot instances. And spot instances are really discount instances which are kind of idle, not currently being used, and that's where we can actually bid on different instances to use them for a lower cost than the typical on-demand cost of an instance. And that's another great cluster policy to enforce is if you know that someone doesn't necessarily have time-sensitive workloads or they're using an all-purpose cluster, or for example, in dev or staging environments, then spot instances are great to utilize and really save in cost quite greatly. And as you see, AWS and Azure both have an ability to understand what are the typical dropout rates of these spot instances, or what is the overall spot pricing history, so that you can kind of understand what kind of cost savings you could have with spot instances. The thing to know about spot instances is the reason why we typically wouldn't use them in a production environment, and let's say a job that has some time sensitive requirement, then is because spot instances can also be taken away at any time. And I think the cloud provider will give you a 2-minute warning or something like that, and they'll ultimately take it away. And so that's where when you set up clusters, you can say that, oh, well, use spot instances, but always fall back on on-demand ones, for example. And so that's why it's important to balance, to use spot instances when available, but then also be able, if you have some time-sensitive workloads, to make sure to drop back to on-demand, or really just don't use spot instances at all when you're looking at production environments. But for experimental workloads, ad hoc queries, dev and staging environments, spot instances are a great way to save money. All right, so that's kind of when it comes to creating clusters and restricting the types of clusters that you can create. Those are some of the main functions of cluster policies that you can use to really restrict, or I guess also provide flexibility for users when creating those clusters. However, there's also other important aspects when creating policies, such as when you want to, let's say, monitor usage of clusters. Cluster policies also allow you to force cluster tagging. So as an admin of an organization, you might have different cost centers that you work with. Let's say, the finance team has one cost center, the engineering team has another cost center. So now with a cluster policy, you can also say, well, because I'm giving this cluster policy to a finance team, I want to make sure that they set their cost center in the creation of their cluster, right? So that later on, these cost centers can be seen on our monitoring page of our billing, so that you can understand, well, that's how much compute was used by this team, and maybe you need to set up a chargeback from that team specifically. So that's what you can do with cluster tagging and cluster policies. And obviously, if you're not enforcing these types of cluster tags with cluster policies, it becomes a lot more difficult to understand what teams are actually creating compute, and how to actually build them and so on. So that's an important feature and we'll get into a little bit of the monitoring aspect of this in a second. Another just quick thing to note is that when you're using instance pools, then cluster tags get propagated down to the VM. Cluster pools. No, I always get confused a little bit by this statement, but generally what it's saying here is that you should create cluster tags on the instance pool, not on the clusters themselves. So it's an important feature of when you're creating instance pools, you make sure that you tag them with the cost center that you want to propagate down to the VM, so that later on in the VM monitoring, you can figure out who is using those instance pools. And this is just an example, right, where we might have a custom tag setting and we're forcing the user to use one of these cost centers. If, for example, they have multiple cost centers that they need to use. Another great aspect of cluster policies is virtual attributes, where we can also allow users to be a little bit more flexible in the type of clusters that they can create. But those clusters that they can create can be based on more of a aggregate view, where, for example, DBUs per hour, so that you can say, well, you can only create clusters that use 10 DBUs per hour, but you have ultimate flexibility on how you want to achieve those up to 10 DBUs, right? And so that's a great feature of what we call virtual attributes, giving the flexibility to users to actually have a little bit more experimentation in the clusters they can create, but we can still make sure that they only reach a certain amount of cost within the cluster that they can create. And then there's also the cluster type where, based on what type of workload someone might be running, whether it's just an ad hoc kind of analysis workload, they would use all-purpose clusters. You could also force them to use job clusters. So if you're giving a policy to a deployment team, job clusters or DLT clusters, so Delta Live Table clusters, are probably most valuable to those teams, while development and ad hoc analysis clusters are probably most valuable, or development and ad hoc analysis teams are most, use all-purpose clusters probably the most. So yeah, hopefully that makes sense. And then, yeah, so those are just some things to know. And I think the other thing is it's important to consider when sometimes I've seen organizations use all-purpose clusters to run jobs. Those all-purpose clusters typically end up costing more money because they have higher rates than job clusters. And so oftentimes it's great to look for any places where jobs are being run as all-purpose clusters and instead use a jobs cluster for that. And we also have a capability of job cluster we use so that you don't even have to use a different job cluster each time for each job. You could literally be leveraging the same job cluster for your multiple jobs. So just if you're ever, giving out these cluster policies and you know that someone is running a job, you should be really pushing them towards using a job cluster, not an all-purpose cluster. And you can do that obviously with policies. And so this is just some examples of that where, you can give a range of max value of 10 so that someone's able to only create a cluster of 10 DBUs per hour. And then obviously also that if they can only create a job cluster. All right, so that's kind of the main part when it comes to cluster policies. There's a few other aspects of costs that we can quickly touch on. It's not going to go into too much detail here, but at least it can give you an idea of where else to look when you're considering costs of your Databricks deployment, right? Because when you deploy Databricks, you're not only using, obviously, Databricks itself, but you're using your underlying cloud provider. And that cloud provider typically does have some of their own costs, but there's ways to really limit those costs. One of those ways is through storage, right? So you're typically using an S3 bucket, GCS and GCP, or Azure blob storage in Azure, and you have a huge amount of data. You potentially have a very large amount of data there, but we can use the vacuum, or if you, let's say you have Delta tables, you can use the vacuum command to ultimately clean up past records of, or rather, past versions of your Delta tables. But it's important to use vacuum alongside with a lifecycle policy. So in this case, this is very specific to AWS, but in AWS, you can create a lifecycle policy which will clean up any of the files that are no longer of use. Because when you run a vacuum command on your Delta table, it marks files that are inactive to be ready for deletion, but it doesn't actually delete them. So it doesn't necessarily open up that space that you would expect with vacuum itself. But then you can create a lifecycle policy on, let's say, your S3 bucket so that you can archive any of the files that are really inactive because the vacuum has been run. And so as you see, the vacuum table being, vacuum table retain policy here is set for 2 weeks. So everything within here is an active, could still be used within a Delta table, but after 2 weeks, it becomes vacuumed and you might want to archive all those old files. And that's where you remove them away from, the more expensive S3 storage into an archive. So it's good to line those timeframes up, vacuuming and lifecycle policies that you might have within your cloud storage. Another one is networking. So when you're thinking about deploying workspaces or after you've deployed a workspace, just to reduce the amount of data that's being transferred cross-region or cross-availability zone, it's good to think about, well, if you're constantly grabbing data from a S3 bucket in, let's say, a different region in AWS, you're going to end up having a lot more cloud costs from that data being transferred between regions. And so you want to always try to avoid that cross-region and cross-availability zone transfer. And also, it's always great to try to avoid using something like a NAT device, so that instead you can use VPC endpoints on AWS, service endpoints on Azure, or private Google Access or private Service Connect on GCP, which allow you to connect directly with on the backbone of these cloud providers without having to go out into public internet, because NAT devices typically are a lot more expensive in terms of data transfer than these types of endpoints that you can create instead to make it a lot cheaper. Another thing to consider is serverless, right? So we are slowly we're obviously offering serverless SQL warehouses. We're soon going to offer other serverless services such as jobs. And serverless is a great way to also save money, where if you look, for example, if you're using a classic SQL warehouse, you might find that there's a Databricks cost and then a compute cost from AWS or your cloud provider associated with it. But with serverless SQL, we take care of the charge both from AWS and from us, obviously. And what's great about serverless SQL is that it leads to faster compute, because you're able to attach to VM right away, right as you write a query, and then you can easily detach from it soon after that. So you're not having to pay for this idle compute between the queries that you run with serverless. And so that can really save a lot of the compute costs by just using serverless over the traditional SQL warehouse currently. All right, so those are some of the ways that we can save money and also control costs with our organization. Now, I also wanted to quickly touch on monitoring, right, which is obviously the other important aspect of cost management, where now that you have users that are using Databricks, you can start looking into the new account console. So on AWS and GCP, we have this account console where if you're an admin, you should be able to log in. That's where you can see all the workspaces within your account. But then there's a page which gives you usage details. So you can understand exactly who's using what. And with those usage details, understand, for example, what workspace is creating, the most DBUs, what kind of jobs they're running, whether it's jobs, all-purpose compute, DLT, SQL warehouse, and so on. You can look at things within different time ranges, and you can even manually download CSVs that include those tags. So when I mentioned earlier cost center tags, for example, those tags will be included in the CSV that you might download from this account console page. And then it's also important to configure daily usage log delivery. So you can actually, which I'll show in a second, you can have an automated way of downloading these logs on a regular basis, so that then you can get notified. You can set up a notebook, for example, that will notify you when usage has gone up too much or it's past your budget or something like that. It's important to know that on Azure, it's because Databricks is a first-party service on Azure, a different method for cost management there, and it's really by Databricks, not only the actual VMs or the DPU usage, but also there is like the networking costs and all that kind of stuff. So you should be able to find that within the cost management center. And what's great is the same way that I mentioned you could download billable logs on a regular basis to understand what you're actually doing over time and maybe analyze it further with a notebook. You can do the same kind of scheduling with the Azure Cost Management Center, where you might be delivering it to a storage container and then from there picking it up on a daily job on a notebook to run through it and create some kind of analytics on it. And so that's where I, like kind of what I mentioned, you can have a notebook that actually discusses how, or rather is set up for you, that will go through and figure out historically what your usage was, and you can actually filter down on the data and see where maybe, you've had a lot of DB usage, right? And there's actually a link to a notebook here, which you can import and start using based on the data that you download on a regular basis. All right, and so I think we're almost done here. I think one last thing is I wanted to mention is for monitoring, we are coming out with a budgets API. So I think from what I last saw, the budgets endpoint, there's a budget endpoint within AWS that's in private preview. And what's great about this budgets endpoint is that you can actually call an API that says, for this cost center, for this team, for this workspace, I want to make sure that I only spend, let's say $2,000 a month or something like that, right? Then what will happen is that you can set up notifications with that API call to tell you once you've actually gone over that limit, so that now you can control based on whether it's your own team or someone else's team, whether we've gone over budget. And so right now, this is in private preview. It will also be an actual UI that we provide as well. So it just won't be simply an API itself, but also a UI. And so that's pretty much it. One last thing I did want to point out is obviously I've shown you the link of the blog itself. However, it's great to also take a look at some of the cluster policy examples in our documentation, which give you some good, starting points to understand, well, maybe there's a way to set up a general cluster policy, or one that's specific for maybe medium-sized clusters or job-only policies and so on. So it's a great place to take a look if you're actually in charge of creating these clusters, or cluster policies, so that you can give them out to the rest of your team. Yeah, and I think that's pretty much it from me. I hope that makes sense. If you have any questions or anything, please feel free to let me know.
That was awesome, Tomas. Any questions from our attendees? Feel free to ask anything you'd like. If you want to go ahead and raise your hand, I can unmute you. There's only one thing that he hasn't mentioned that is useful for me. If you can name your jobs and your job clusters, like the clusters you use, or I guess really all of your clusters, based off your projects, it makes it a lot easier for me as an SA to help you figure out how much each use case is maybe costing you and whatnot. So that kind of information is something that is helpful for your solutions architect. Since we can't see your tags the way you guys can see your tags.
I 100% agree. And so I see one question. Can you please share the link info on the notebook you showed earlier? Yeah, sure. And I think you're talking about the notebook around analyzing your spend, right? If that's the case, then it should be, I think that, I don't know, Stephanie, do we typically share these PowerPoint presentations with the rest of the group later?
Yeah, so when the recording goes out, we'll also send out a PDF copy of the presentation, and the links in there should work for you. So that should be fine. And awesome. Look, Toby's got the notebook linked, so that is in there as well.
Yep, exactly. So that'll be in the presentation, and we can share it there. And I can also share it here if take a look. All right.
All right. Well, thank you so much for presenting today, and thanks for attending. Everybody have a great rest of your week.
All right. Thank you so much. Have a great day, everyone.